Okay, so this is my video analysis of my dynamics problem set. I'm probably just gonna make one video for this, but I'll see what I want to do. So I just first started off by writing all the given values, and then I explain it here. So I found the radius by actually pausing the video at 52 seconds, 52 seconds within the video. And then I just used the scale to determine 0.27 meters from the center. And then you actually need this radius to solve the entire question, so it was necessary to find this, as well as finding the time between how long it takes for Einstein to fall. And using that, I just basically wrote down the steps of what I wanted to do. So by now I would have found the radius, found the time period, and now I was still deciding whether or not I should use the normal force, but I did find the normal force regardless of whether or not it was required. And then I also decided to use a UCM equation to solve for the static friction coefficient. And here's my free body diagram. And so if you look at the Y point of view, this is an accurate representation of what the forces all would look like. Centripetal force being towards the wall, which is equal in magnitude to the normal, and the static friction being equal to the gravitational force. But if you look at just in general, the only thing that is really pointing towards the center is the normal force. And because the normal force is the centripetal force, technically you'd be only having the normal force towards the center, and there wouldn't be really any centripetal force. So yeah, normal force would be the net force in this situation. So, and then at the top here, I also wrote 240 frames per second, just for clarity. And then if I look at the second part where I actually find my results, so if you look here, I also highlighted the things that are important. So the normal force is the only force that is actually pointing towards the center, like I said before. And I also determined that to find the time it takes to do one revolution, I need to actually do, once again, a frame by frame calculation. So I looked at the 56th frame and up to the 221st frame, and then I basically divided 156 over 240, which is how many frames there were between these, and then I basically got 0.69 seconds. And then yeah, basically by that point I had already determined the force of static friction equation, which was the force of static friction is equal to the coefficient times the normal force. So based on that, I just rearranged it for the normal force, and I also determined that based on one of the questions I had previously done in the unit, and based on the equations that we knew coming into this problem set, I could use the GT squared equation and the over 4 pi squared r in order to actually determine the coefficient in a much more efficient manner. So to be honest, I didn't even really need to find the normal, because this equation actually doesn't require me to find the normal, and then I would have to rearrange it in order to find the coefficient. So this saved a lot of time for me, actually. And I just plugged in the values. I used the 0.69 squared, right? And then times the gravity over 4 pi squared and the radius in meters. And then I multiplied these, I got the products, and then I divided them, and I got a 0.438 as my coefficient, or 0.44. And here, just as a bonus, just to make things more clear and give myself an idea of, like, would this result be actually accurate in a realistic situation, I just used the exact same equation here to determine the normal force, in which I got 3.36 newtons. And knowing that Einstein was a little doll that was stuck against this like wooden board, I thought that this value for the normal force was actually pretty accurate. So I followed through with this value. I was happy with it. And here's my therefore statement, and then here's my dimensional analysis. So yeah, I hope that was a good explanation. And if there was definitely one thing I would change, and I think it's an important one, I definitely changed how I organized my notes. So I feel like I could have just written all my explanations at the start, and then I wouldn't have to, like, especially for like marking this, like, and highlighting, I wouldn't have to look around and like, oh, like, okay, well, here I explained that the normal force is the only force pointing to the center, and well, over here I also explained that the radius and how I got it and why I got it. So overall, I was generally satisfied, but there was also some organization skills that I could have enhanced for this problem set. Thank you for listening.